would not have this trouble of icing. But then, you see, you'll get fed up with the fridge in the end, and you'll dump it to get a different design. So the question is, how good do you have to make a power unit for it? How long will you keep that design? That's another point you have to consider. And this is something we have to decide. Because if we say that you'll get fed up with the machine you've got, you want a new design, then we could say that probably using very cheap material will give you 5 to 10 years use. That's another thing we have to look at.
They could be modules, too, that could be interchangeable.
Yes, that's another point which we can consider.
How would you stop an SVG? How would you stop an SVG?
Well, the easiest way to stop it, and I advise you not to use the poker, is to have an oscillator. You have an oscillator which produces the frequency that that particular plate is printed at. Now, that was, again, a sheer accident. It was in Canada, 1971. I was doing TV shows with this generator. And every place was all right till I got to this one place. It's in the book. You see the TV station that this took place at. I was sitting there, and I just said, and I think they said there were about 50 million people watching this demonstration live. I just said, I built this in 1956, and it's never stopped running. And the silly thing stopped when the camera came. And of course, I was quite smiling till that happened, and of course my face went the other way. The camera pulled back to show my face, and the silly fool started again. Now, immediately that happened, I knew why. That camera had an oscillator system on it. When the film got to it, it printed that film onto it. Wiped the others off, so the roller stopped. The first one stopped, the lot stopped. When they pulled it back to show my face, the thing started again. Of course, my face went the other way then. Here we had a system, accident or sheer accident. Nobody knew that was going to stop, except it. It didn't tell me, or otherwise I would have told everybody, watch out and may stop. Now, this is what I'm trying to point out. These sheer things that happen at the most awkward time generally tells us the answer of what we're solving. We would prefer that to tell you that before the show, not during the show. Right, so now we know how to stop it, and we know how to start it. And it's taken all those years to do that. And 50 million people have to watch me solve that problem.
The ion effect on health has been mentioned. Have you had any indication if this might help AIDS patients? There was a device here earlier that was presented, paper being passed around for electric current going through the body, but do you know anything about your effect on AIDS patients?
Well, I've never had the chance to test this. We do have a medical section in the USA who is very keen of this technology to go into the burns unit. We are very much discussing this. This looks a very good project. Whether it could be used other, we know it's good for asthma, we know it's good for bronchitis. It clears it from the system. But whether you burns, well, burns is really an open effort, and so if you have big cuts, I would say you'll benefit from that machine. At least the pain would be eased immediately, and it would assist the healing. But other than that, I wouldn't not be able to say.
Mass-produced, what would it cost for the size unit for an automobile? What would be the lowest?
Well, if you really was mass-producing these, and I don't see why you could not get the price down to $500. Which is nothing, really. But you have to consider, once this machine is in the car, You never have to stop for petrol. So when you pass a petrol station, you can wave it goodbye. The second thing is you have no pollution. So that's another thing you've got to consider. Again, there's one other point you've got to consider. On a nice cold morning where everybody else is scraping the muck off the screen and they can't get the car to start, you have got in, turn on a few seconds, the heating, because your mains power has cleared all the screens for you. You are away. And you can shout out, why don't you get an SEG to the others and hope to sell them? But I would say, in seriousness, I think we can get it down to $500 a unit, because of the millions that would be needed.
How do you get the power out of it?
Well, the power is it's simply because the electrons are being forced to move in one direction. As they've been forward pushed, they've been squeezed. The squeezing is making them speed up. When you speed something up, you're actually opening up space, which means you can put more in it. So the further you go forward, the more compression comes on them, and the more you're opening the front. As you know, if you get a sponge, you squeeze it, the end you squeeze in goes in, but the other end free tends to expand. It's the same sort of thing. Because you are pushing it and sort of speeding it up, you are bringing in more kinetic energy. So you're carrying an immense force. When you get to your last roller, the power leaves. Now, if you let it go in the room, you're obviously making the positive state of the room negative, which, of course, makes you feel better. Your headache's gone, and you do the chemical people out of a lot of money because you won't need Aspros anymore. But you don't have to clean the floor or the room, no more dust, because dust can only exist in a positive state condition.
Couldn't you build the SEG with 1 or 2 rings to keep the cost down?
Well, with 2 rings, you may not have enough force there to get enough electrons to pump into the coils. What you're doing here is that instead of having a positive state on one side and then simply deflecting those electrons, you are putting in more electrons so that there's much higher electrons, so you have a potential difference in the negative state, so that all the surrounding area is reduced to a negative state. And that is really what you want in the room, because it is the positive state that makes you tired. The more positive it gets, the more tired you get. In fact, after all, what your brain is doing, the poles of the little drops of water are all trying to turn one way to that surrounding field, that positive field. And the more you're trying to turn them the other way by trying to work, it is resisting you. So you eventually, if you overdo it, you get a headache. But this condition does get rid of that state. Not only that, it gets rid of the dust at the same time.
On the rings erased, are they rotating at the speed that matches the rollers?
Yes, you've got to define what frequency you want, the number of coils you want, because obviously...
But the ring doesn't move.
The ring, it's the rollers that are moving. The rings must be held, because if you don't fix them to a casing, they will basically be drawn as the rollers start rotating fast. They will pull them round as well. So you would lose energy in the process if they move.
How do you get the rollers to start rolling?
They self-start.
Once you just set them in there?
Yes, you just put one in, and away it's gone. Now, when you drop the next one in, when it passed the point, it separates itself to equal position. Drop another one in, they again separate themselves. At all times, they always keep themselves at a certain distance apart.
You get a positive charge state in the center of the disc?
Positive charge in the center of the disc.
Now, in a disc, you don't have a charge there at all. The charge on the shells come short of the center. So at the center, you keep it clear because you've got to pick up signals from the ground. You've got to have a radio communication point, and we take it at the center. If you take it at the edge, you'll get interference from the fields. You'll get interference from other material the craft is drawing into itself.
Yeah, I was wondering how you do the radio control.
That the only radio point for communication is at that center, at the weakest possible point of electron movement.
On a one-ring system, can you magnetically couple to that moving ring and use just turbine effect to operate the system?
Well, you can, but it's the fact that you haven't got the power there, the kinetic force that you need to get the power. But it's not any reason why you can't use it for different concepts. Yes.
You can use that. So
Yes. You said that the thing is, you can use a single ring and you can do all kinds of things with it, but the question is how much power you want from it. If you want power, then you've got to boost up the force that you can obtain from the device.
You mentioned the interference with radios and televisions and things. If we had a whole bunch of these devices running around, wouldn't that pretty much wipe out our communication system?
Well, you wouldn't have in the case of the discs because you would have them very high up. The reason this happened is because in those early days the field that we had was so large. We had no knowledge on what field should look like. It wasn't until we got on TV too much about making rings and ripping the earth up that we started to get concerned that we might get a big bill from somebody, that we start to look at this problem. A lot of people came together and we looked at it, and what they thought was happening is that the field itself was sort of focusing down, inwards at a sort of cone shape. And the force there, being focused, heated the ground, and thus picked up, causing a suction effort, and lifted it up. And the thing was, it got to a point with so much publicity that we had to think of doing something about it, because I feel sure that farmers were getting a little bit concerned. And when the rings of the cornfields occurred, I can tell you, I was hammered by people if I was doing it. After all, I was known to do a lot of queer things in the name of research. But they never called it research. They gave it another name.
Once you have the motor installed, how do you capture energy from it to another use?
Can't quite hear it.
Once the motor's installed in the disc,
Yeah.
you're talking about, how do you tap it for use? What? Okay, no. In an SEG, how do you tap the power?
Just by coils, as you do in any other electrical motor. You wind the coils for your output. Now, this magnetic device is a prime mover. It does not produce electricity in a true sense. You have to wind coils to get the conversion. The concept of electricity production is that you either move the magnetic flux and keep the conductors stationary, or you move the conductors and leave the magnet forces the flux stationary. So you have two choices. What I picked was that the magnetic flux should move, keep the coil stationary. To me, that saves a lot of problems.
What's the gravitational field inside of the graph?
Well, inside, all measurements done on models so far has shown but half a G. In other words, it's half of what we read here on the ground. Constant, yes. That's because the circle force is coming inwards at all points. So what happens here, as far as I can see from the instrument readings, is that you feel better, but from NASA's study and work they've done, they suggest that if you're a long time in less than that, the heart muscles shrink. So if you get less than that, you would have to go through a special unit where the heart could be strengthened slowly back to this normal. But as far as we can tell, all the manufacturers checking the charts say that it stays stable at half a G, which means that you feel a lot better, but your heart won't shrink in the process of a long stay on board. Just think of it. If you travel in this craft and we accelerate at 2 Gs, constant from start, you are 20 years old. You travel for 20 years out constant. You then stop, return. You have got 20 years slowing down, 20 years return trip. How old are you? How old is the Earth? The Earth is 40 million years old from the day you left. But you are only 60 years older. That is what Einstein was trying to tell you. He was telling you that the faster you travel, the slower the time becomes. So your clock on your ship seems to run the same time as it does here, because it is in constant motion with the vehicle. The Earth is not in constant motion with the craft. Therefore, as you stretch space, the Earth is shrinking space, and it's accelerating. People on Earth carries on just the same. You carry on just the same. The difference is when you get back and you find what the human being has done to the planet, that you realize you were better off when you went.
Is that half G, does it stay half G even when this craft is accelerating?
Yes, because the whole craft is like a planet, like you're sitting here now. The G, the 1G, will not change. You are always subject to 1G. Now that's at the speed. You're traveling at this moment 139,500 miles per second in one direction. At the same time, you are traveling 110,000 miles a second, almost right angles to that line. On top of that, your solar system effort, you are traveling at 19.8 miles per second. All this motion is going on while you're sitting there, but you don't feel any difference whatsoever. You can move about and do what you like because this planet and you are related. What goes up out in space does not affect you, and that's the same with this craft.
Can I bring us down to Earth and ask some questions? How many discs did you eventually build and what size?
Well, the first 6 we lost, as I explained the other night, and they ranged from 3 feet in diameter, and we went up to the biggest one, the last one, that was not the last one before the last, was 40 feet. Now you may want to know what the weight was. But that first one weighed about 12 pounds. That 40-foot one, that weighed 40 tons, a ton for each foot. The demo one, which is so famous throughout the world because the media had an open door to watch us do it, weighed 21 tons. Again, a ton per foot.
How did you lose them, though? How did you lose them?
Well, the first ones we lost because we had no way of knowing what was going to happen. And funny enough, the man was a Welshman. His name was George Haynes, and he was dying of cancer. So he had money, and I had been telling him about what I'd been doing and what I thought we could do, and he loved it. Because to him, he was very religious. To him, people walking with their heads down was wrong. They should be looking up. And he said, John, if you think you can put something up to make people look up, I'm with you. He called his son and said, take John down the market and get him everything he wants. And he did. I made the device as I saw it. And when we released the last little pin and let the last roller go, then the thing just shot up again. To me, that's a silly thing to do, because by all laws, it should stay there. Gravity should be holding it, it's so heavy. But it went airborne. And then we had all this trouble, and then it went. And of course, I had a friend who didn't like it, and he decided, he let me know he didn't like it by an air gun. But George, he loved it. He didn't know what I was putting up with. But you see, he could hear people shouting about, look at that thing up there. And he was happy. I was happy for him. I only wish he knew what I was putting up with. And he said, John, make another one. I couldn't work out how I was going to stop this thing.
So they just went off into space, huh?
Yes, it just went shot off. We have to assume that the kinetic energy is such that there is no way of it falling back to Earth. It just goes on and on and on.
Didn't you say that some of them got stopped by the ceiling?
Yeah, that was the inside ones. The early ones with my landlady.
Big question. How come we don't have one now?
Well, it's because the materials are costly now. It was more or less giveaway then. That's the only reason.
Small one? 3 feet.
Well, those we did in the house started off about 8 inches.
Okay, 8 inches. How much to make one?
Oh, we're looking at quite a price, aren't we?
You need a cheapo rare earth.
Well, we're probably looking at £100, 200.
Less than $1,000.
Possibly a lot of work. We got to make molds for them. They have to be made exact. There is no such thing as a cheap and dirty SUV. One motor. It has to be made exact.
How so you can get on tape?
It has to be made exact specifications. So whether you want it small, you want it large, it has to be exact. That technology is time consuming. So it's not a real cheap situation. And we are now working towards something that's usable rather than something that you can demonstrate for a toy or to just show it.
I would think if you showed somebody that this thing would shoot up and stay in the ceiling, you'd have more money than you know what to do with.
You probably would. You've got to have it. We're just starting again.
Okay.
Yeah. Well, we're looking at, an answer to the problem. How do you capture the mind of a person today? Not yesterday, they wasn't interested to put money in anything strange. Today, they may be. After all you people have been shouting enough, they should now be interested in such a bar. What we did propose was to have a bar, something simple, with 3 or 4 rollers running around it. Something very simple, which people can look at all day long, wondering when the battery will run out. And you tell them just stay there until it stops. We'll bring you the jerry can in for you to use in the meantime.
What's the timing schedule for that? Dollars and schedule. The dollars and schedule to put one on the table.
Yes, that's just on the table, yes.
How much would it cost?
What we reckon to Jeff. But this is what Jeff wants to do.
This is being done privately. This is being done in a small lab. I can't tell you how long it'll take because one hasn't been made yet. If you want time and money, I can't give you those exact figures. We have to figure out the dimensions and the cost of the elements, work it out, and put it together as we press. So it would take ideally 2 to 3 months to get one built, and I would estimate approximately $1,000 for a small single unit.
Yeah.
You said you had the rollers already built.
No.
They're being built right now.
They are being built. They're being checked to make sure that the rollers don't crack.
That's what takes time. We got to solve the cracking problem, which is a common problem when you first start pressing the material. The next problem is when you got that right, you have to leave it for 3 weeks to be sure it don't disintegrate. If it don't disintegrate, you're ready to start working and producing them.
John, can I point out that at $20 each, one lecture this size gets you $1,000?
And considering that this is the first time Professor Searle's lectured in the United States, I'll take it under advisement.
Yes! Right.
Yeah, back to the motor car. If an SCG is driving a car, when it goes around a turn, is there a centrifugal force that would restrict it like a gyroscope?
Well, if we put these in the wheels, then each wheel, as the load come on, the load controls the running speed. So as you turn, the outer wheels would accelerate.
So each
As you
wheel
see,
has
so you count. Now when you level, they will go back to normal. It's instant. The changes are instant. So you could really zoom round a corner, 100 miles an hour, and you wouldn't tip over because the wheels would go at the speed required to keep it balanced. In fact, for racing cars, they're wonderful way of doing it.
You said the largest you made was a 40-foot unit.
Yeah.
Whatever happened to the bigger units?
Well, that big one, once we finished the work we wanted to do to prove that between that and a 38-footer, that the power energy work out. So what we were trying to do is to find out how much energy, based on the same formula of the squares, by going larger is. And what we find out is this. The power of that difference between those two sizes is about 100 million volt difference. So that engine is a powerful thing by just going up a few levels of the square. So it is studying the squares and working them from the base up until you get the force you want. It tells you what the force is that you'll get from this 0 point to that level. The calculation you get there is the amount of force per roller that is going into the system, the driving force. So you get a gigantic roller. You're not going to hold that, or then you're not going to stop it, because the kinetic energy is so great, and it's that kinetic energy that is your workhorse in flying. That is what holds it up there. So if you judge that weight just right, so it's just about to leave the ground, you could go underneath and lift it. And you could say to people, I bet you can't do it, and then turn the pod down.
You want to know what happened to the 40-footer?
Well, the 44-footer, we stripped to use the material for the next one. The trouble is, once you've done something, prove what you want. Because they're unmanned, you can't really use them for anything much. So when you pay out all that money for something and you've done the research you want, then you strip it and you make the next one. And that means we then go down to a smaller size, make it. And everyone, the idea with everyone is to try to solve a problem, to find out if the thing works better this way or that. There's no books on the subject. Even NASA can't give you any information. You've got to find it and give it to NASA.
You take some current rare earth magnets as they exist today, even though they're high cost, wrap some nylon around them, wrap the copper or iron around them, compress them down.
Well, no, because the way they've been made, they are sort of all twisted and bashed together material, so that the material itself is in random motion.
Secure that in the middle.
Yes, we have to set it so that when we put the powder in, we have got them in uniform motion, but in such a way that they are all working in a switching, a pumping action. Now, you can tell which one is which because you can put a meter across the normal one and you see the resistance is very high. You put it on the one that's done by our system and the resistance is extremely low, that you can identify which is which just by meter.
John, you mentioned when you chop the roller into 8 sections.
Yes.
Do you do that before you magnetize it or after?
Now, when I first started, we started first with solid rollers and found that all that happened is that they just stayed there. That's all magnetized. It just stayed there because you've got a complete loop. You've got to put something in there So when we make the things now, we just work out the whole volume of that roller, then we divide that by 8 to get the 8 segments, and we make one part at a time.
That's 8 sections along the axis?
Yes, yes, so they're discs. And you print each one. Now the whole picture's different. No?
Okay, three more minutes.
Yes. We got 3 more minutes. We can either do one or two things. We can have a good sing-song, or anyone got a question?
Why didn't the RAF come out and shut you down and take your disc?
They tried it. I don't know if you heard the news here in America. In Cyprus, when one of the discs went across, 2 RAF aircraft were sent up to investigate and to shoot it down if it did not obey the commands. But you see, we had a chappie who told us, you've got 2 MiGs on the back of you. So all we did is just slip it up, shot it round, and the 2 jets went a bit out of control, and they decided to leave it alone. And after that, the British government, I haven't got the paper now, gave orders to the RAF command not to send fighters up when they see these objects, just to ignore them. And a funny thing too, I like to put this in before we ran. When I was in the RAF, we had this, what is really a mesh wire aerial, so that you could signal in all directions for the craft. And this, when I left, I forgot to take it down and take it with me. The base commander wrote to me and he said, Mr. Searle, do you want us to pack this flying butterfly up and send it to you? And we did print that letter in very old newsletter. I'm afraid I haven't got that newsletter. It's burnt, but maybe someone somewhere has that old one. Somebody today I met knew me from 1956. And if anybody at that time got the newsletters, you may scan through, see if you can find that letter and send it to me, because I like to put that in one of my books, because when you read it, it's funny. Well, I'm sorry the time has came to an end. I've thoroughly enjoyed meeting you all. I hope when we got the thing up and running, you'll all come running back.